Math 8, Unit 5, Functions, Lesson 1, Part 1, Relations and Mapping Diagrams. First, let's look at some examples. Here we have a green rectangle. It's got a height of 2 and a base of x. I've got a selection of inputs we're going to pick from, and our output will be the area. When we select the input of 1, that's going to make x equal 1. The area is going to be base times height, 1 times 2, which will give us an output of 2. Next, we try a different input. When we do the input of 2, now x is 2. Now this is a square, 2 by 2 square. 2 times 2 is 4. When we try our next number, which will be a 3, we'll get a rectangle that's base of 3, height of 2, area is 6. And when we do 4, we'll end up getting 8. In general here, when I input the x, the output is the area. It ends up being 2 times bigger than x, whatever x was. Nice little relationship there. Now let's look at the same rectangle. We'll change its color, but now we're going to look at perimeter. If I try inputting an area of 1, or not an area of 1, a base of 1, the area will be 1 plus 2, not area, perimeter. The perimeter will be 1 plus 2 plus 1 plus 2. That is 6. If we try putting in a 2 for the base, now it's 2 plus 2 plus 2 plus 2. That is 8. If we later go and do the input of 3, 3 plus 2 plus 3 plus 2, doing the full perimeter, is 10. And this actually follows the pattern down. If we have a base of 4, we end up getting a perimeter of 12. Actually, in general here, whatever my x is, the perimeter ends up being 2x plus 4. So this is actually a linear relationship as well. Okay, we're going to describe the pattern in the mapping diagram and complete the diagram. On the first example here, the input of 1 gives an output of 8. The input of 2 gives an output of 10. 3 goes to 12. What do 4, 5, 6, and 7 go to? Well, what you might notice here is that they are going up by 2. That's a pattern we can use. So this next one, of course, would be 14. 5 would go to 16. 6 would go to 18. And 7 would go to 20. Just following that pattern down. Now, generally speaking here, there is an equation that could be used to get from one to the other. And we learned how to find these equations in Unit 4. We used a y and an x instead of an m and a t. I'm just using m and t because that's what's in the mapping diagram. But I can just double the input and add 6. Like 1 doubled is 2 plus 6 is 8. And that works for all of these. Okay, this next one. You'll notice 1 goes to 4/3, 2 goes to 5/3, 3 goes to 2, which, by the way, is the same as 6/3. If you look at this pattern, it looks like it goes up a third each time. So it's just going to go 7/3, not 7/8, 7/3, 8/3, 9/3. 9/3, of course, is 3, and then 10/3. And that's what it would fill in with. In general here, the rate of change is 1/3. So it's just a equals 1/3 x plus 1. The reason I know it's 1, if I go back to the input of 0, following the pattern, it would be 3/3, which is 1, giving us that as our equation for this relation. Now, we've been doing some relations. We haven't called them that really yet. We need to know what that means. First, ordered pairs. Ordered pairs can be used to show input and output. The ordered part is because the number that comes first is different than the number that comes second. The input is different from the output. Now, if you take a set of ordered pairs together, you get what's called a relation. A relation pairs inputs and outputs. A relation can be represented by ordered pairs or a mapping diagram. There's actually other ways too. It can be in a table. It can also be graphed. The ordered pairs of 0, 1, 1, 2, and 2, 4, you can see in blue are the inputs, in red are the outputs. And over here in the mapping diagram, which is new to us, we have the inputs in a bubble and the outputs in a bubble, and each arrow shows the input going to the output. Let's list the ordered pairs from each mapping diagram. Well, the ordered pairs, each arrow gives us an ordered pair. 1, 3. 2 goes to 6, so that's 2, 6. 3 goes to 9, that's 3, 9. And 4 goes to 12, that's 4, 12. Those are all the ordered pairs in the mapping diagram. Every arrow becomes an ordered pair. On part B here, 0 goes to 0. Now 2 is an interesting thing because it has two different arrows coming out of it. 2 goes to 1, and it also goes to -2. So we would include both of those ordered pairs in our list of ordered pairs that's in this relation. And then the last one is 4, -3. 4 arrows give you 4 points. Okay, let's continue with that, and this will be our last example of this video. List the ordered pairs shown in the mapping diagram. Well, 0 goes to 12, 2 goes to 10, 4 is going to go to 8, and 6 goes to 6. And that's all of the ordered pairs in that relation, shown in the mapping diagram. This last one here, looks like 1 could go with -1, and 1 can also go with -2, giving you those 2 different points. 2 can go with -3, and 2 can go with -4, giving us these 4 ordered pairs. There is a second video in this lesson.